Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to explain you the concept of hash indexes and bitmap indexes, or hash indices and bitmap indices. So before going to explaining about hash indices, what is meant by indexing? What is meant by index or indexing? So index is nothing but the records which you are going to retrieve the data all will be treated as one bucket or one storage, one cluster, so that all the clusters will be treated as an index, So to retrieve that records through this index, we are going to use the search keys to retrieve the values. So based on that search key values, based on that indexing mechanism, we are going to retrieve the data from storage area. So there are different types of indexing mechanisms actually. So bitmap is one index type of mechanism, hash indexes is one type of mechanism, B plus trees indexing is one type of mechanism. Among that all mechanisms, what is meant by hash indexes or hash indices? So applying hash function to the index, is called as hashing. So here hashing can be used not only for file organization. So especially hashing can be used for file organization. So here it is not only for file organization but also for index structure creation. That means we have to create the index. We have to create the indexes for everyone, for every search key values, for every pair of pointers, pair of search key values. We have to create an index structure also. So to creating the structure and to organizing the files, the hash indexing mechanism or hashing mechanism is very useful, very important. So a hash index organizes the search keys. So hash index organizes the search keys. That means it arranges the search keys to retrieve the data. So with their associated record pointers. That means we already said that what a node structure contains what, either pointer followed by search key, followed by pointer, followed by search key. So like that, here hash index organizes the search keys with their associated record pointers. So as the indicates that what it is associated with record pointers into a hash file structure. So strictly speaking, hash indices are always secondary indices. If the file itself is organized by using hashing, a separate primary hash index on it using the same search key is unnecessary. So using primary hash index on it using the same search key is unnecessary. So you can use different search keys for different indexes, different secondary indexes, different primary indexes. So for the file organization, to file the retrievation, we can use the primary hash indexes or else secondary hash indexes, but not use the same search key for all the indexes. However, we use the term hash index to refer to both secondary index structure and hash organized files also. So the term hash index refers to both secondary index structures, to creating secondary index structures, and hash organized files. So this is the what we have to understand from what is meant by hash index. The hashing is only for using file organization and for index structure creation. But how the structure is created and how the search key values are paired with the pointers, that is nothing but what, a hash index. Hash index or hash indices. So example of hash index. So here the hashing mechanisms allows creating more number of buckets. And each and every bucket contains all the records. And each and every bucket contains search key values also. So the bucket pointed with the data block, bucket is pointed with the data block. And from this example, in the bucket has index on instructor on attribute ID. So here the search key value from this examples, the search key value is what? Is ID, instructor ID. So here you can see this is instructor ID, and this is instructor instructor name, and this is instructor course, and here instructor salary. So to fetch the records of data structure data block for any of the record, the first search key values are created with the buckets. Search key values are created with the buckets. So here the bucket 0 is identified one ID, bucket 1 identified two IDs, but bucket 2 also identified only one ID, bucket 3 also identified one ID, bucket 4 is does not having any IDs, so that the bucket 4 is doesn't have any search keys, nothing but it wastes the space. It wastes the space that we created for the search key values. And bucket 5 also created, bucket 5 also with the two search key values, along with the secondary indexes also, along with the secondary hash indexes also. So this is the primary hash index, and this is the secondary hash index. Primary hash index having two values, and from these the secondary hash index also having two values. And similarly bucket 6 also having one search key value, and bucket 7 also having one search key value. Now based on the search key values presented in the buckets, that all the search key values followed with the pointers, right? So search key value is what indicates k, and the pointers indicates what p. So p1 followed with k1, similarly p2 followed with k2, like that it follows the node structure. So here the bucket 0 having one search key which contains 76766. Now this search key pointed to the particular record where the actually data presents. Now this search key value pointed to this particular record which you want to fetch as based on the record. It identifies and it fetches. Now you can fetch this record because the search key value is presented on bucket 0 record. And similarly bucket 1 also having two search keys. So one search key is for 145565. Similarly it is pointed to the particular 45565 record, and similarly 76543 is also pointing to the next record which is having 76543. So like the way each and every bucket having its own search key values, and based on the search key values it refers to the data to fetch the records. And here if bucket is not having any search key values, the bucket goes waste to the space. The bucket goes waste to the space. So at that moment this is what disadvantage on hash index. If bucket is not having any search key values, then the bucket storage is wasted. So at that moment what we preferred a dynamic hashing mechanism. So at that moment dynamic hashing moment we can create the buckets dynamically for the search key values. So here the bucket 5 contains two indexes. One is what? A primary index, and the second one is what? Secondary index. So here the secondary index point out what? 33456 is pointed to the 58543. That indicates 33456 search key value is pointed to the 58543 search key. Now 58543 search key value is pointed to the particular record which you want to display. And similarly 98345. This is also a record which is pointed from the first primary indexes record. So this is the primary hash index and this is the secondary hash index. So like that, primary hash index and the secondary hash index are used to find the records that we are going to fetch the record from the database. Bucket 6 also having same, bucket 7 also having same. So here from this whole example, we can say that we can create more number of hash indexes, like that we created primary hash index and secondary hash index. And also we can say that the wastage of the buckets also, the storage space wastage of bucket also overcome with the help of dynamic hash index. So like the way we can use the search key values in the bucket and which pointed to the particular records to fetch the records, particular points of the records to fetch the records. So this is the way of understanding how hashing mechanism works and how hash indexes are created. How hash indexes are created. And next, bitmap indices. So bitmap indexes are bitmap indices. So bitmap indices are a special type of index. So bitmap indexes are also a special type of index designed for efficient querying on multiple keys. Efficient querying on multiple keys means we can write the queries. We can write the queries based on the multiple keys. Multiple keys. So multiple keys are nothing but what? We can have a instructor ID from the previous example. We can have the instructor ID from the previous example. Here, the instructor ID is one. Instructor ID is one search key value. Similarly, if you take instructor department name also a search key value. So now take these two are the search key values. What one is ID comma department underscore name. These two are the search key values. These two are the search key values. That is nothing but multiple keys. So bitmap indices are a special type of indexes designed for efficient querying. So efficient querying on multiple keys. And records in a relation are assumed to be numbered sequentially from say 0. So that all key values to be, all records to be stored in bucket or data block will be from a sorted order, that is 0 to 1 or 1 to 2 to 3 like that. So 0 to 10 like that, the sequential order to be maintained. And here, given a number n, it must be easy to retrieve record n. So give any number of record, give any number of search key, and it must be easy to retrieve record. So the way you are thinking that what the number which you are assigning, the number which you are given in the bucket is to must be easy to retrieve that record, and particularly easy if records area of fixed size. So particularly it is easy for the fixed size of the buckets, fixed size of the records, because the fixed size of the records will fetch a lot of values. So at that moment, pick up any values which you want to retrieve the data, and applicable on attributes that take on a relatively small number of distinct values. So applicable on attributes. So attributes are nothing but those columns values, and applicable on attribute that take on a relatively small number of distinct values. Small number of distinct values. So example gender, which contains the attributes like what, male and female, like that. And similarly country. So country is having for countries, states, like that. These are all some types of attributes. And the example income level also. So income broken up into a small number of levels. So ranges of the attributes. Attribute ranges also given. So here 0 to, we can create the indexes. We can create the indexes for 0 to 9999, 10,000 to 19999. That means the indexes are created for the frequency of the ranges. Indexes are created for the frequency of the ranges. So at that moment, the fetching of the records in between these two is to be easy. So range Range, providing the range is for only easy retrieval. Providing the range is for only easy retrieval based on the indexes that you are appointed. Indexes that you are appointed. And a bitmap is simply an array of bits. A bitmap is nothing but what? Simply an array of bits. An array of bits. So it contains either fixed size or variable size. It contains either fixed size or variable size. Bitmap indices count. So bitmap indices count. In its simplest form, we can write it into the simple form. A bitmap index on an attribute has a bitmap for each value of the attribute. Each value of the attribute. So the bitmap index on attribute has a bitmap. For a bitmap is nothing but a value for each value of the attribute. So for each value of the attributes indicates that what? A bitmap. So here the male indicates what? One bitmap, 10010. Similarly, a female gender indicates what? Bitmap 01101. So that is the bitmaps that we are giving for indexing mechanism. Bitmaps that we are giving for indexing mechanism. So here income level is added based on the bitmaps. So here we can create the bitmaps. So bitmaps for income level, and the income level is added in the table. So here bitmap has as many bits as records. Bitmap has as many bits as records. In a bitmap, for value v, the bit for a record is 1. The bit for a record is 1. If the record has the value v, if the record has the value v for the attribute and is 0, for the attribute the bitmap record is 1 if the record has the value v. For attribute and it is a 0 otherwise. That means the bit for record is 1 if it contains value. If doesn't contains value means it doesn't shows any value. So indicates that what? 0. Indicates 0. So here the record numbers and the IDs. So 7666, and the gender similarly 2222. This is one ID. This is one ID. This is one ID. This is one ID, and this is one ID. So creating with the gender attributes. For all these gender attributes, the income level is added here. And the income level processes that what? Bitmaps. Income level is processes that what? Bitmaps. And here the bitmaps are created. Bitmaps are nothing but what? As like array bits. So simply an array bits. So simply an array bits means we applied here. So L1 is what? 10100 is one bitmap. Similarly, L2 is 01000 is another bitmap. And L3 00001 is another bitmap. And L4 00010 is another bitmap. And L5 all zeros is one bitmap. For all these bitmaps that are added into this table with the income level L1, income level L2, income level L3, L1 and L4 and L3. So like the way the bitmaps are created as array bits are created, and for each and every bitmaps we assign that attributes also. For each and every bitmaps we assign that bit also. We assign that bit also. So for each and every bitmap having its own attributes. So gender is one attribute which contains both male, female, male, female. So for each and every male, female, the bitmaps are added here. So this is nothing but what? Bitmap indices. These are all nothing but what? Bitmap indices. So here bitmap indices are useful for queries on multiple attributes. So bitmap indices are useful for queries on multiple attributes. So if any table of any index having multiple attributes, then it contains what? It contains that useful for bitmap indices are useful for them. So not particularly useful for single attribute queries. Not particularly useful for single attribute queries. But it can have more than one attributes, then it is definitely used. Bitmap indices are used because bitmaps are created for that attributes. So you can assign the bitmaps for particular attributes. And the queries are unanswered. Queries are unanswered using bitmap operations. Using bitmap operations. What are the queries? We can use them as intersection is one query, and union is one query, and complementation is one query. So questions are answered using bitmap. These all the queries, these type of all the queries, intersection related queries, union related queries, complementation related queries are all using with the bitmap operations, because all that operations, all that queries will be having more than one values, more than one values or more than one attributes. So at that moment, more than one attributes are indicating with the bitmap indices to find out easily. So here, each operation takes two bitmaps of the same size. So each and every operation takes two bitmaps of the same size and applies the operation on corresponding bits to get the result bitmap. So to get the result bitmap, the two bitmaps of the same size and applies the operation on the corresponding bitmaps. So see here, example, if you can take 100 100 110 and 1100 11, is if perform this if we perform under operation on these two bits, if we perform under operation on these two bits, then we'll get 100010 as the result bitmap. So how we'll get, see here, so 01 is what, 0, and 11 is what, 1, and here we'll get complement, and here 0, and here 0, and here 0, and here 1 1 is 1. So like the way it gets the result bitmap. And while performing same of R operation on those two bits, R operation on those two bits, this is AND operation, and for OR operation also same OR operation. So 100 110, and here 110 011. So for if perform OR operation, so it takes the 01 as one value, and 11 as also one value, and 10 also taking one value, and 00 also taking zero value, 01 one value, and one value. So 110 is the result bitmap. So result bitmap. So this is all about bitmap indices. Bitmap indices are created. Each operation of two bitmaps of the same size will be performing this intersection operation, union operation, complementation operation. So here performing these complementation operations. So here complementation operation is directly on single band. And males with income level L1 10010 and 1010. So this is all the operations based on these levels. This is all operations are based on these levels. So result bitmap. So this male and male. So we'll take what the result bitmap. Result bitmap for intersection operation. Result bitmap for union operation. Result bitmap for complementation operation. So like the way we'll perform all these operations. And bitmap indices generally are very small compared with the relation size. So bitmap indices are generally are very small compared with the relation size. The relation size is nothing but what? Table size. So as like table size, bitmap indices are very small compared with them. Example, if record is 100 bytes, the space for a single bitmap is 1 by 800 of space used by relation. 1 by 800 of space used by the relation. If the number of distinct attribute values is 8, if the number of distinct attributes value is 8, then bitmap is only 1% of relation size. So that indicates that what, that's why the space occupying the bitmap indices is very small compared with the relation size also. So that is what we understand from this bitmap. Bitmaps are very small because of the comparing with the indexes or comparing the relations. And here we can create the indexes. How to create the indexes in SQL? We can create the indexes as like creating in the tables. So to do that, what is the syntax here? So create an index. How to create the index? So create index and index name. So same like what, create a table, then next to table name. Same like creating of the table. We can create the indexes also. So create index name on relation name. That means the table name. On what table we are creating indexes. On what table we are creating indexes. So mention the table name. Example here, create index b index on branch table. So in that branch table we can take as a branch name as search key value. Branch name as search key value. So like the way you can create. So as like creating the table, we can create the index also. So create index name on table name. That means the relation name. And use create unique index. Use create unique index. That means we no need to create multiple indexes with the same name. So create unique index to indirectly specify and enforce the condition that the search key is a candidate key. So search key is a candidate key and is a candidate key. So search key is a candidate key. So whatever the search key we are providing, we are giving is the candidate key. So it is not really required if SQL unique integrity constraint is supported. So not really required. If you are applying integrity constraints, then no need to create a unique index because it already applies with the integrity constraints. Similarly, to drop an index. So how to drop the table? So drop table name. In the same way, drop table name. In the same way, we can drop the index also. So to drop the index, drop index name. So drop index name. So here index name is what? B index. So this is the way we can create the index and we can drop the index. We can create the index and we can drop the index. And most database systems allow specification of type of index and clustering. So most database systems allows specification of type of index and clustering. Type of index and clustering index. So this is the way of creating an index and dropping an index, and how we are creating the indexes for easy accessing mechanism or fast accessing mechanism. So this is about index, and just we revise the topic which once we discussed it till now. So here the first topic is what, hash indices. So what is meant by hash index? So index is nothing but what, creating an index for all the records to access very fastly. And here hash index organizes both files as well as index creation of the structure. So here the example of hash index works here. So all the buckets will be having the search key values, and the search key values are pointed with the pointers. Each and every pointer is followed with the search keys. Again, search key values are pointed with the pointers. So each and every bucket having search key values which are pointed to the particular records to retrieve or display the values. And similarly, if any bucket is not having any search key values, then the bucket space is wasted. So at that moment we can use the dynamic hashing method to create a buckets dynamically if really wants to store search key values. So this is the way of creating buckets, and here the primary hash index and the secondary hash index also applies. The next, bitmap indices. So bitmaps are nothing but simply like as an array bits. Bitmaps are nothing but what? Simply like an array bits. So these bitmap indices are applied on multiple attributes. So this is very special type of indexes designed for efficient querying on multiple keys actually. Multiple keys. So example, gender is one example. which contains both male and female attributes, both male and female attributes. So here the bitmap indices table we can see the for that all attributes we can create a bitmaps and that bitmaps are added into this table. All bitmaps are added into this table. So if performed, these bitmap operations are performed on union intersection complementation operations especially. So here after performing that operations, to perform that operations, the two bitmaps are equally same size. The two bitmaps are having the same size and apply the operation on corresponding bits. We'll get the same result of bitmap. We'll get the same result of bitmap. And it performs only on AND operations, instruction operation, complementation operations. And here the bitmaps indices are very small compared with the relation size also. And index is creation. So how to create the index in the SQL? So create index name and relation name as mentioned in the syntax. So creating an index is easy, and to drop an index also easy. So this is the way of creating indexes and using bitmap indices and hash indices. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.